Okay, we've spent a couple days now talking about derivatives of inverse functions, both trigonometric and other functions that are inverses. All we're going to do today is use those rules about taking an inverse derivative that we've learned in the past, and we're going to apply them into position, velocity, acceleration, tangent line problems, any application problems. So let's warm up by taking the first derivative of some trig functions, of some inverse trig functions. The first derivative here, I'm just going to use the basic rule, is 1 over the square root of 1 minus x squared. Now, since it's just an x here, there's no 2x, there's no 3x, there's no x to the negative third power, the derivative would just be 1, so I'm going to stop there and I'm done. Here in this problem, the derivative of inverse tangent would be 1 over 1 plus the square root, 1 plus 2x squared squared, times the derivative of the inside stuff, which in this problem would be 4x. If I simplify this, I get 4x over 1 plus 2x squared squared would be 4x to the fourth, and I'm done. Now, using what we know about derivatives, let's see if we can answer this question. A particle moves along the x-axis so that its position function is this guy. What is the velocity of the particle when t is 16? Well, to figure out velocity, I know I need the derivative of position. So let's start by figuring out our velocity function. So v of t equals. The derivative of inverse tangent would be 1 over 1 plus the inside stuff, which is the square root of t squared, times the derivative of the inside stuff. Now, I like to think about the square root of t as being t to the 1/2 power. So I would have 1/2 t to the negative 1/2 power as my derivative. When I simplify that, I get 1 over. Now the 2 is going to go on the bottom. This t to the negative 1/2 I'm going to change to a square root of t. And then I have 1 plus a square root squared would make a regular. My last part of the question here is, what is the velocity at 16? So all I'm going to do now is plug the number 16 into the problem wherever I see a t. So I'm plugging in the 16 here, and I get the 16 here and here. When I do that, I get 1 over 2 times the square root of 16 is 4 times 17, which would be 8 times 17, which I believe is 136. So your answer would be 1 over 136. And you're done. Find an equation for the line tangent to the graph of inverse cotangent at -1. We know that if we want to write a tangent line equation, we need a point and we need a slope. To figure out the point, I'm going to use the -1 that they give me as my x value, but then to figure out the y value, I'm going to need to plug it in here. So to figure out y, I'm doing inverse cotangent of -1. What this really means is, where is the value of cotangent equal to -1? That's what I'm trying to figure out. Where is the value of cotangent equal to -1? So, because of the way that the unit circle works, I know that the place where cotangent is -1 would be negative pi over 4. Now, if I want to figure out the slope, I'm going to use the derivative. So y prime would be negative 1 over 1 plus x squared. And I'm just going to plug in the -1, and I get -1 over 1 plus -1 squared, which is -1 over 2. So last but not least, my tangent line, you can't see what I just wrote down, just kidding. Write that down. Woo! Last but not least, my tangent line equation would be y plus pi over 4 equals -1/2 times x plus 1. And that would be my final answer. Okay, that's it. I will see you guys tomorrow. We will do some practice questions and have a great night.